This conference will now be recorded.
Hello, everybody. Jordan Girth here from the National Weather Service Office of Observations. Thank you for joining us for the Satellite Book Club Seminar Series. This is session number 109. Hope everybody's doing well. Hope everybody's summer is going well. Today's presentation, Chasing Watts, Water, and Polar Bears on the Arctic Tundra and Sea Ice. Our presenter today, Jen Delamere, Research Associate Professor in the Snow, Ice, and Permafrost Group at the University of Alaska Fairbanks and Director of the Geographic Information Network of Alaska, or GINA. Our facilitator today is Jeremy Michael, meteorologist at the Weather Forecast Office in Tucson, Arizona. Just a few reminders before we get started that this session is being recorded. There will be an opportunity for Q&A after the presentation. We encourage questions, particularly from field offices and regional headquarters. If you haven't signed in with your full name, please note your full name when asking the question so that we can follow up with you if necessary. We're always looking for future presenters, so please contact the TowerS team if you're interested in being part of our Satellite Book Club seminar series. And the training team can help create training materials that may be unavailable or you may be unaware of. Brian Mata with the Office of the Chief Learning Officer can help with that. I'd like to thank our TowerS team, particularly Kashad Bowman, the Office of the Chief Learning Officer, GOES-R JPSS program for their support of the book club. And of course, thanks to all of you for being with us today. Without further ado, I'd like to introduce Jen, who studies the Arctic environment from the ground in space. Her research focuses on precipitation measurements and the spring melt in northern Alaska. Jen is also the director of the Geographic Information Network of Alaska, an organization delivering direct broadcast satellite products to Alaskan stakeholders. Having held jobs in the software industry, academic research units, and self-employment, Jen's career path has been anything but traditional, but she wouldn't have it any other way. Jen, we're glad to have you at the Satellite Book Club. Thanks for being with us today.
Okay, am I taking over from here?
You've got it from here.
Okay, well, this is really a fake title. This talk is actually about wildland fire in Alaska, but I just wanted to give a little background on myself. Thanks, Jordan, for that introduction. I have spent most of my career working in Alaska, but generally doing ground-based research. So I've spent countless hours on the North Slope of Alaska, studying atmospheric radiation, creating radiative transfer models for forecast codes, chasing water under snow, and hopefully not being chased by polar bears. Next slide, please. But in the spring of 2020, when the COVID pandemic was taking over the world, I had an opportunity to start to study Alaska from space. And who wouldn't take that opportunity after doing so much work in the field? So here is Alaska, 665,000 square miles. It's a big state, only 18,000 miles of road and 1.3 people per square mile. It's a fascinating state with incredible amounts of volcanoes, 50 active volcanoes, lots of wildfire, and fabulous moose. So what is it I'm going to talk to you about today? I'm going to talk to you about the GINA aspect of my job. That is direct broadcast applications as applied to Alaska. Next slide, please. So here at the University of Alaska Fairbanks, we have an incredible direct broadcast facility. We have two antennas, one located on the UAF campus. We call that antenna affectionately Big Dog. We have a second antenna located at a NESDIS facility just outside of Fairbanks. UAF works with NESDIS, and it's a great example of a federal academic partnership. And on and off over the years, we've had access to data from an antenna in Nukiavik, which is in northern Alaska. Using these three antennas, we are fortunate enough to receive data from 9 polar orbiting satellites, including the JPSS satellites SNPP and NOAA 20. Next slide, please. So data comes in around the clock from this series of 9 satellites that we receive. You can see that, so as it comes in, we send it through a processing stack located on the Fairbanks campus. These 2 antennas, the data comes in through antenna control computers, arrives in a big stack of computers powered with CSPP software to generate hundreds of products daily, from level 0 to SDRs to level 2 products. These products are then available to the public via public web portals, web pages, servers, and also the data is transmitted via LDM to AWIPS users such as the National Weather Service or members of the fire weather community here, like the Alaska Interagency Coordination Center. There's a lot to remember here, but I'd like to direct you to our website, gina.alaska.edu. We give a great description of all the direct broadcast products available. And at this juncture, I'd also like to thank SIMS, who produces the CSPP software that makes this all possible. Next slide, please. So today I'm here to talk to you about wildland fire in Alaska. So GINA at the University of Alaska Fairbanks works closely with the Alaska Fire Service. They prefer to have their products delivered via hosted map services so they can embed them in both NIFC web apps and their own web apps, which I'll show you in a minute. So the series of products that the Alaska Fire Service uses in their daily assessments of fire. So we provide them via these map services 4 products from NOAA 20 and SNPP. I'll just briefly describe them, but I also refer you to some of the work that Curtis Seaman has done at CIRA. He's got excellent blog posts about these products. So we provide the True Color RGB, which is what you see with your eye. It's a combination of 3 channels, sensitive to visible light. It's a great product for delineating surface types like desert from snow, as well as atmospheric features like clouds, smoke, and dust, where smoke, for example, can be particularly blue and hazy. And you can see in this top left image, kind of in the center, those are plumes of smoke on the south central Kenai Peninsula here in Alaska. If you move over to the top left, you'll see the Dayland Cloud Fire RGB, also known as the Natural Fire Color RGB. This combines 3 channels that have sensitivity to smoke, vegetation health, and active fires, in particular small fires. The advantage of these top 2, or this product, the Dayland Cloud Fire, is it's got a 375 meter resolution. The disadvantage of the top 2 products, True Color and Dayland Cloud Fire, is they're only available during daytime hours. However, in Alaska in the summer, we don't have too much nighttime. The bottom 2 products, bottom left is a fire temperature RGB. It's useful for qualitative estimates of fire activity and intensity. It's also available at night. And the bottom right image is an example of the I4 band from VIIRS, or the 3.74 micron shortwave IR channel. The single channel is excellent for day and night detection of fire. It's also the basis of many fire-related products. It shows only the brightness temperature from these fires. So unlike the Dayland Cloud Fire, you don't get a lot of information about smoke or vegetation. But the real gold standard that we use is the panel on the right. Those red dots are the NOAA active fire algorithm output. So they represent fire detections, and they're an excellent measure of fire extent. And when you overlay those on top of the Dayland Cloud Fire RGB or the I4, you really can get a good estimate of the perimeter of a fire. Next page, please. So after all, I said I would speak to you about the Alaska fire season. So the next sequence of slides will get at just that, and I will be showing examples from this fire season. So there's many, oops, sorry, go back a slide, please. There's many people to thank, a number of groups at the University of Alaska Fairbanks. Eric Stevens and Heidi Strader, they are our they're fire weather experts here in Alaska. Jen Jenkins at the BLM Alaska Fire Service, and many of you who are on this talk here from NOAA, JPSS, and the Weather Service. Next slide, please. So there were two parts of the title of this talk: the Alaska fire season on the left side of the title, on the right side of the title was the view from JPSS. So I just want to quickly review why polar orbiting satellites are so important, and in particular the VIIRS instrument. So we get a ton of coverage here at high latitudes. So if you combine SNPP and NOAA 20, we get up to 18 passes a day. So on the right side, this is a graphic. It's a bit hard to see the outline of Alaska, but the big orange swath in the middle represents the area in northern Alaska with the most coverage. So again, that's 18 passes a day, combining SNPP and NOAA 20. You come south to the central interior of 10 to 12 passes per day. And down in southern Alaska, both in the Juneau area and over in the Aleutians, we get 6 to 8 passes per day. So that's a lot of coverage. Next slide, please. So pivoting back to what the wildland fire season has looked like so far this year, it's been an incredible season. We've burned over 3 million acres since the beginning of the year. We have had 557 wildfires. We've had up to 6 complexes of fires, which means fires have merged together. And at the peak of our fire season activity in June and July, we had almost 2,000 people assigned to working up here. We're at 312 now because we've had some rain. So the split between fire causes is largely equal between human and lightning cause, but out of these 3 million acres, only 11 million acres are attributed to human-caused fire. So it's safe to say this year, lightning has really driven the fire season. Next slide, please. So pivoting back to the view from JPSS, if there's one thing you can take home with you today is that Alaskans were hot and frustrated with smoke in June and July. The state was covered in wildfire smoke, pilots couldn't fly, kids couldn't go outside and play, and we were basically, there were instances of hazardous air all over the interior and as far out as the West Coast. Next slide, please. So here is a graphic of the cumulative burn starting April 1 every season since 1993. So the record-breaking component of this season is if you see the pink line in the center, that's the 2022 season. We reached 1 million acres by mid-June. So that was the fastest climb to 1 million acres thus far in the history that we've been keeping. You can see we climbed very quickly, but we tapered off in mid-July due to rain. So it is not likely, in fact, almost impossible at this point that we'll be in the top 3 fire seasons. You can see that the 2004 season, the top in orange line, we burned almost 6 million acres. Advance, please. An interesting part of this season was we had fire in the tundra in April, Southwest Alaska, 10,000 acres burned. That was pretty incredible. Advance, please. And just for perspective, so far this year in the United States, we've burned close to 6 million acres, so that includes Alaska. The Canadians are at around 2.5 million acres. Next slide, please. So this gives you a sense of how urgent Alaskans feel about wildfire this season. So this is a graphic of time versus preparedness level. We recognize up to 5 versions of preparedness across the country. Each step up means more resources are being tossed at the region, and incident teams are being dispatched to complexes of fires. 5 is the highest level. The United States is currently at level 3. So you can see how fast we climbed through these preparedness levels. When we get to level 4 and 5, it's all over the media that the state is having an emergent wildland fire season, and we all have to be extremely cognizant. Next slide, please. This is a graphic from the Alaska Wildland Fire Information Map Series. This is where you can go to get all your information about wildland fire in Alaska. This is a snapshot from yesterday that shows blue fires are considered out, red fires are still active, so you can see the distribution is huge. And we have 3 fires that have exceeded 200,000 acres. Next slide. So this is a time series of how the fire season developed using the VIIRS active fire detections. So you can see in May how we're building up, and we build to this incredible crescendo that happens in late June and early July. And then the rain fell and we felt relief. Next slide. So how did this get started? So I'm just going to take you now through an anecdote of a fire called the Hog Butte Fire. So in early June, there were about 5,000 lightning strokes that happened in southwest in Alaska all the way up into the interior. Next slide. Within hours of these lightning strikes, fires were appearing. This is just a close-up near Denali National Park. These fires ended up being complexed later in the season. Keep going. Next slide. So early in June, it was recognized that that series of wild lightning strokes were really going to cause trouble. So smoke jumpers were loaded into aircrafts and deployed to Southwest Alaska. Next slide. So while the fires were burning, aircraft was out. This is an image from a fire I'm now going to talk about in a little bit more detail. This is Hog Butte Fire number 185, just north of Denali National Park. So the planes were out just after the lightning, June 5th and June 6th. Keep going, next slide. So this is just a little insight into how GINA operates. So we know that fires are going on. We're tracking them with these active detections, and we're working with the Alaska Fire Service to assess how these fire points are, their accuracy, and how well they're being used. So we here at GINA use Slack. So I just went back to our Slack history and picked out a couple of images because we were going back and forth on Slack about how these fires were exploding using all these great tools from JPSS. So on the left is before a perimeter was drawn, fire points covering about 8 square miles. On the right are those points overlaid on dayland cloud fire RGBs in near real time. Next slide, please. So while we're here really focusing on the fire points and making sure our services are running for the Alaska Fire Service, those over at the Alaska Fire Service, their incredible GIS team, are drawing fire perimeters. Their first options are to use Landsat or Sentinel because of their high spatial resolution, but Landsat and Sentinel, you only have coverage every few days. So VIIRS is often turned to draw the fire perimeters. They're drawn in ArcPro using Esri products with imagery and fire detections. Jen Jenkins at Alaska Fire Service sent me this image of how she was assessing the Hog Butte fire perimeter. Next slide, please. So now I'm going to take a 2-minute diversion. I want to just stop here before we advance to the next slide. So while I was actually on the North Slope digging snow pits in early June, and while fire was exploding in the interior and southwest Alaska, my son, Sam Delamere, was climbing Denali. Denali is a massive mount of mountain, 20,000-foot summit. And from his climb, he was able to photograph the Hog Butte fire. He also got stuck at base camp because of the massive amount of wildland fire smoke. But during all of this, the National Weather Service Fairbanks office is putting out forecasts tailored to climbers on Denali. I would like to thank Carl Dierking and Lee Byerly for enabling direct broadcast fire heat points from CSPP active fire software to be ingested into AWIPS. So Lee and Carl took some infrastructure that was already there from the TowerS RPMs and wrote a script that enabled the ingest of fire points from direct broadcast data. So these are now available to the NWS Alaska as well as other fire weather specialists here in Alaska. This is a graphic from the Tutlawixic fire, which happened just the same time as Hog Butte in the very same area. On the left, we have the Dayland Cloud Fire RGB, and on the right, we have the VIIRS I4 image. The dots represent different strengths, fire radiative power, and one tiny feature to point out is there is an area of saturation in the southwest corner of this graphic, which you can see really well in the VIIRS 3.74, and on the Dayland Cloud Fire, it's harder to tell, but this was a very intense fire. Keep going. Next graphic. So 2 more time series. I want to just show you Hog Butte fire, how the perimeter couldn't be drawn as fast as the fire points were showing up. This is a progression of Hog Butte fire, and the red lines are coming behind the fire points, and perimeter drawing was eventually done with VIIRS, a combination of Landsat and Sentinel. Okay, you can advance to the next slide. And this is a wider region, same concept. Basically, the fire points from CSPP active fire algorithm are leading the perimeter drawing. Go ahead. This is another great example to see how many fires emerged from lightning starts in the area north of Denali National Park. These fire heat points are just vital to what we do with fire management here in Alaska, because when these red spots are detected on a map, resources are dispatched, both detection aircraft and sometimes smoke jumpers. Go ahead, next slide, please. This is one more GIF of just some smoke plumes that we captured from AWIPS. This is made possible because we have so much coverage from the VIIRS satellites. You can show it one more time, or from the JPSS satellites carrying VIIRS, because we get so many passes a day. Okay, go ahead to the next slide. And just to wrap up, a few more just still graphics. Again, I mentioned I was up on the Chukchi sea ice, so this is mid-June on the sea ice. It's a little hard to tell from these images, but wildfire smoke had traveled all the way to northern Alaska. Pilots were having trouble flying. It was pretty incredible. Next graphic. By the end of June, early July, the city of Nome on the west coast was breaking air quality records with toxic levels of smoke over a few-day period. Next graphic. So then what happened? It rained a lot. So what was a basically abnormally dry conditions in southwest and south central Alaska in early April and across the interior gave way to extensive rain, and the fire season came to a halt. And I'd like to thank Eric Strader and Eric Stevens and Heidi Strader at AICC for providing incredible forecasts every day and giving a little relief to Alaskans when the rain is coming. However, they just declared winter is almost here, so I have mixed feelings about their forecast today. Go ahead, next slide. And this is just a graphic from my absolute favorite fire of the summer, Fire 406 on the North Slope of Alaska. Essentially, I'll just read this to you. The Greater Prudhoe Bay Fire Department reported a fire. There had been a caribou obstructing a runway in Dead Horse. Airport personnel attempted to drive the wildlife off the runway using small explosives deployed from shotguns known as bangers. In the course of these operations, the runway was set on fire. Thankfully, no one was hurt. Next slide. Just a final report card. It's been an incredible season. We'll have a final report for everyone in October of 2022, but we continue to assess active fire algorithms. We're expanding the role of the VIIRS IO4 in the portfolio of remote sensing products. We're working with colleagues here at UAF on air quality, being able to get near real-time information on aerosol optical depth coming out of our direct broadcast system out to the public. And we want to expand tools available to pilots during smoky conditions. And last slide. Finally, I've gone through a lot today, but if you have any questions or you have a story you want to tell about Alaska and you need near real-time imagery to do it, feel free to email us at satellite@gina.alaska.edu. With that, I'm done. Thank you.
Thank you, Jen. That was a great and informative presentation, so I appreciate that. We're now going to move into our question and answer session, but before that, I want to really encourage participation from the field forecast offices as well as any regional headquarters personnel or just anyone joining for the presentation. And when you're asking a question in chat, please type in your full name. And also Lee just posted in a feedback survey, so if you wouldn't mind taking a few moments and clicking on that and filling that out, that helps the Satellite Book Club series greatly, so appreciate that. And a little bit of housekeeping before moving into the question and answer. The SBC will not meet next week due to the AMS Collective Madison meeting, but will resume the following week at 12 noon Eastern on Thursday, August 18th, as Brian Curran, Science and Operations Officer from WFO Midland and Texas, will discuss the Hermley, Texas EF2 tornado case. And then also, please contact the Tower S team, Lee Byerly or Kashad Bowman, for questions about the SBC or for configuration of satellite products. And now we're going to move into the question and answer session. So again, if you want to ask a question, you could indicate that you'd like to ask through the camera or the verbally, or please type it in. And we'll pause for a moment for to see if we have any questions. If not, we'll move on with some more. Mike, yes, please go ahead. Mike, you might be on mute. We can't hear you.
Yeah, Jeremy, I think you're on mute.
Oops, apologies. Yeah, I'll ask the question while the audio is not coming in. And Mike, if you wouldn't mind typing that in, and then we can get that question out. But in the meantime, Jen, what's coming next in GINA's effort to improve services for wildland fire managers and fire weather forecasters in Alaska?
Well, we have all this incredible data, but there's more we can do with it. So we have a project likely coming up in November that will expand different algorithms we use that will help us assess, get a better assessment of wildland fire, especially start and extent, using different algorithms, in particular Mike Pavlonis's Volcat algorithm. We are also looking at ways to expand an alert system that would be effective for wildland fire managers. So, for example, if a wildland fire manager has an area of interest and they want to know if there's a VIIRS detection that shows up in a certain perimeter, basically, can they be alerted? Those are the types of things we're working on. So better detection in cloudy situations and better alerting to the fire managers in a way that's effective for them to use.
That's great. Thank you, Jen. And yeah, I encourage everyone, if you have a question, please pop it into the chat, or you're more than welcome to verbally ask the question. We still have about 10 minutes. And Mike, if you can hear me, you can also type that question into the chat and I can ask Jen.
Well, there's always extra video at the end of the presentation on smoke jumper deployments. So one thing about Alaska is there are a couple of sites of interest, akfireinfo.com or org, I can't remember, and I can't pop it into the chat, but if you want to read incredible stories about what our wildland firefighters are doing, AK Fire Info has incredible graphics, fabulous YouTube videos, and there's an infinite wealth of material available to Alaskans. So that's another piece that I didn't really stress. The Alaska Wildland Fire Map Series has the detections. It has this imagery that you've seen here from GINA. It has the lightning stroke count. It shows the perimeters of fires, and it's all available to the public. So in late July or late June, when this was really exploding, I think we had over 300,000 requests to our map service coming from the BLM main web app. So Alaskans are really engaged in wildland fire. Obviously, we have to be because it's pervasive. There's excellent partnerships here with the National Weather Service, WFOs, and the fire weather specialists for, that work the fire weather in the summer. I think we have a great story to tell here in Alaska about how federal agencies, partner with state agencies and with academics, and mostly the public too. Some of these VIIRS images are, shared on Facebook from the National Weather Service Fairbanks. They get thousands of views. Climatologist Rick Toman uses these images to help Western Alaskans, not only with how the sea ice is moving during the year, but what's the fire season look like over in Southwest and Western Alaska. And I just think Alaska is a fabulous example of how people can come together in really tough times.
Thank you, Jen. And we have a couple more questions now. We'll go ahead with Mike's question, since he was trying to get that in there. And also to note, there are some links popping in there that are good resources that were discussed. Thank you, Owen and Matt, for placing those in the chat. But Jen, this is from Mike, and thanks for a great presentation in every aspect. Do you think that more staring satellite versus polar orbiters would improve your fire alerting and monitoring capabilities?
Okay, so this is where my lack of expertise shows up. I'm not entirely sure what more staring means, but one thing I will say, and Mike, please elaborate, and someone else that knows more can probably jump in, but we do have a gap in coverage in the evening. So we do not have coverage from about 6 p.m. local to midnight. So SNPP and NOAA 20 are not flying over the state then. So we have a gap there. Our resolution at best is only 375 meters, which is fantastic. So you get frequency, but we do miss those evening hours where we don't have coverage right now. And so if we were able to use new satellite technology to get that capability, of course we have GOES, but with parallax issues or clouds being in the way, once you get into interior Alaska and northward, you get quite a bit of, I don't know if warping's the right word, of the pixels. And even Denali can cast a shadow when you're looking at GOES. So I'm not sure I answered the question, so apologies.
Thanks, Jen. And yeah, Mike, if you have a follow-up question,
Oh,
feel free to
yes.
put that in there.
Tundra orbiting, yes. So the answer to that is yes. So I've sat in on some conversation in which the experts have talked about this, and I believe that there may be some satellite technology coming up with a tundra orbit, and which we'd be able to somewhat replicate what a geostationary satellite does. So yes, thank you.
So the next question, this is from Mary. She's from the Seattle National Weather Service Forecast Office. Have you been able to use similar techniques for the eruptions and the elutions?
Absolutely. So I only talked about fire as it is on the ground and smoke plumes, but we work with the Alaska Volcano Observatory and the National Weather Service Aviation Unit. So the same type of fire detection happens for volcanoes. So if you follow our direct broadcast products, there are red dots that pop up all over the elutions, hundreds of them actually. And in addition to those, we pass on VIIRS near real-time products to Alaska Volcano Observatory, where we can do things like derive SO2. We get a sense of the ash index. So the same story can be repeated for volcanoes, and it is repeated. In fact, it's been going on since the late 1990s, and I'd be happy to share information offline about where you can get this data or tools you might have from an NWS office in Seattle or in that region. So thank you.
And we have another question. So how are preparations proceeding for the launch of JPSS-2, and how will these new data streams affect efforts with wildland fire management?
Well, I don't really want to say anything too bad now, but SNPP, it looks like it's well on its way to recovery, but so hopefully that'll be the case. So right now we have SNPP and NOAA 20 from the JPSS suite. When NOAA 21 launches on November 1st, I believe it is going to go a quarter orbit ahead of SNPP. And then as boxes are checked and we move forward, NOAA 21 will eventually become the primary. NOAA 20 would be the secondary, and SNPP the tertiary. So we'll have 3 satellites flying. All of this technology is exactly applicable to JPSS-2 or NOAA 21. So we'll have a massive amount of coverage. So if you imagine if we have 18 views right now of northern Alaska, you can add a whole nother 9 or 10 coming from the new satellite. And SNPP will continue in direct broadcast mode to my knowledge as long as the satellite is healthy. So we're really excited to have more data coming in. Again, the thing we'll lack is sort of that evening coverage when fires can be active here in central and northern Alaska.
And another question, this is from William Roberts. What kind of coordination do you have with Environment Canada?
So great question. Environment Canada does pull some of our data, but at the fabulous CSPP software conference in June, I made some additional contacts with Environment Canada to see how we can push our direct broadcast to help them. Also, we do get detections in Washington, Idaho, not many, but they are there and they're available. We see down to those latitudes a few times a day. So Environment Canada is also looking to expand their direct broadcast capabilities, even putting a new antenna in northern Canada so that we can just keep building up this picture from direct broadcasts. So thank you very much, William, for asking that question.
Thank you, Jen. And with that, I will pass it back to Jordan for closing remarks. Thank you, Jen.
Thank you.
Okay, well, thank you so much, Jen. I really appreciated that perspective, and thanks, Jeremy, for moderating. Sounds like we had some great questions today, so thank you to all. Once again, I would like to just highlight we are off next week due to the Collective Madison meeting and NOAA Satellite Conference in Madison, Wisconsin. So for those of you that will be there, I look forward to seeing you there. Our next meeting with the Satellite Book Club together will be Thursday, August 18th, and we're going to welcome back Brian Curran, who's going to discuss the Hermleigh, Texas EF2 case. So once again, if you have any questions about the Satellite Book Club, please get in touch, or the configuration of satellite products, please get in touch with John Evans and Lee Byerly of our Tower S team. Also, Kashad Bowman can help you out, or you can reach the team in the NWS chat. So that's going to be it for now. Once again, thanks to our presenters today, and thanks for all of you for being with us. We'll see you in 2 weeks. Take care, everybody. Bye-bye.